Today, we are diving into something big. We're not just talking about a new app or a software update. We're exploring a seriously ambitious theory that wants to rebuild our entire digital world from the ground up, using a framework built on some truly advanced mathematics.
So just imagine for a second, what if we could just start over? No more patches, no more band-aids. What if we could build a digital universe that was fundamentally fair, totally secure against future quantum computers, and could scale to infinity? I know, it sounds like science fiction, right? But that's the core promise of something called Digital Fabrica Theory. It's a massive claim, so let's dig into the design.
All right, so to really get why such a radical idea is even on the table, we first have to look at the cracks in the foundation we're already standing on. What are the big, nagging problems that even the most promising Web 3.0 projects are wrestling with right now?
Well, the source material boils it down to three huge limitations. First, scalability. It's a massive bottleneck. You have a network like Ethereum that can, handle maybe 15 to 30 transactions a second. That's just not going to cut it for global adoption. Second, we've got quantum vulnerability. The encryption that keeps everything we do online safe today could basically be shattered by the quantum computers of tomorrow. And finally, there's a big governance problem. A lot of these so-called decentralized systems end up with power clumping together with the richest token holders, which kind of defeats the whole purpose, doesn't it?
So how in the world does Digital Fabrica Theory propose to solve all of this? Well, it starts by completely changing the way we think about it. It tosses out the old metaphor of blocks on a chain and asks us to imagine weaving countless fibers into a vast digital fabric. Let's unpack what that really means.
At the very core of this idea is the fiber thread. This is your basic building block, kind of like a smart contract, but it's not a static, dead thing. Each fiber has these dynamic, almost physical properties. You've got tension, which could represent its current computing load, and elasticity, which is its ability to adapt to what the network needs. You have to think of them as living, responsive threads of code. And of course, when you weave all these dynamic fiber threads together, you create a digital fabric. This fabric is the network. It's the application. It's the organization itself. It's not a rigid, brittle chain, but a complex, resilient tapestry where the whole thing is way, way stronger than any single part.
And this slide just lays it out perfectly. On the left, you've got that classic chain idea. It's linear, it's sequential. If one link breaks, the whole thing is in trouble. But on the right, you have the fabric model. If one thread gets damaged, it doesn't bring down the whole structure. The threads around it can adapt, pull together, and maintain the integrity of the whole system. It's just inherently more resilient.
All right, this is where things start to get really wild. We're going to peek under the hood at the math that makes this fabric even possible. But hey, don't worry, there isn't going to be a quiz. The whole point here is just to understand why they chose these mathematical ideas and what they unlock. This is such a cool concept. The theory suggests we can actually measure the health of the entire network by looking at these collective properties. So, fabric tension tells you the overall stress on the system. Elasticity shows you how adaptable it is, and something called the entanglement score is basically a measure of how well all the pieces are working together in harmony. You're basically creating a vital signs monitor for an entire digital ecosystem.
And now for an idea that is truly out there, baking ethics directly into the network's mathematical code. It's called the Zeta-Pi-Theta ethics kernel. Zeta uses properties of the Riemann zeta function, which is all about the distribution of prime numbers, to mathematically guarantee fair resource allocation and stop power from piling up in one place. Pi grounds the whole system in objective universal constants, like the number pi itself, to take human bias out of the equation. And theta makes sure the rules are applied the same way, always, over time. So this isn't just a social promise to be fair, it's trying to enforce it with pure math.
You know, a brilliant theory is one thing, but how do you actually make it real? This is where Digital Fabrica Theory gets surprisingly practical. This isn't just some dusty academic paper. It comes with a super detailed master plan for turning this mathematical dream into a real-world business. Let's check out the roadmap.
So, the whole adoption strategy is laid out in three very deliberate phases. Phase 1, in the first 6 months, is all about building the foundation, getting the tools out there, running small pilot programs to prove the tech actually works. But then, and this is the crucial part, Phase 2 is about going big by bringing in major institutional partners. This is not a build-it-and-they-will-come strategy. It's about getting top-down credibility early. And only after that solid foundation is set does Phase 3 kick in, aiming to scale to over 20 major deployments.
And to make all that happen, the plan spells out exactly who does what in this new digital economy. It's a 4-tiered system designed to work together.
At the very top, you have Tier 1, the big institutions like governments or huge companies deploying their own sovereign networks. They're supported by Tier 2, the professional services firms who do all the complicated integration work. That then opens the door for Tier 3, the individual developers building all the cool tools and smart contracts. And finally, Tier 4 is all of us, the people actually using the apps built on top. It's a complete vision where every layer supports the next.
And this slide right here grounds that whole strategy in financial reality. Just look at the projected revenue for the first year. The biggest slice of the pie, by far, comes from institutional contracts. That sends a really clear signal about the business model. Focus on providing high-value infrastructure to big, stable organizations from day one, instead of, relying on some speculative token sale. It's a surprisingly professional approach, and it's built for the long haul.
And now, we get to the final section. This is where the true, jaw-dropping scale of this theory's ambition really comes into focus. Because when you dig into the source documents, you realize that rebuilding the internet, that's really just the warm-up act. The ultimate vision is something far, far bigger.
Get this, the entire system, the whole shebang, is designed inside a single, unified geometric framework that has 14 dimensions. And that's not just some random number picked to sound impressive. Each dimension is meant to represent a fundamental piece of the system, from physical space and network structure all the way to the rules of its economy and its governance, all of it woven into one unified mathematical model.
And that leads us to this powerful quote from one of the core documents. All recursion converges into you. All cosmology radiates from you. I mean, at this point, we're not just talking about technical specs anymore, are we? This is philosophical. It points to this ultimate goal of creating a digital universe with a coherent, logical origin point, a system that is, in some weird way, self-aware of its own structure and its own purpose.
Which leaves us with the big question. Is Digital Fabrica Theory the actual blueprint for the next digital revolution? A quantum-proof, ethically governed, infinitely scalable internet? Or is it a beautiful, impossibly complex theory that's just destined to remain a fascinating idea on a whiteboard? The blueprint is there, but the story of whether it can actually be built, well, that chapter hasn't been written yet.